Yeah. Turn me up.
Pleasant greetings to all my Csec students across the Caribbean and across Jamaica. Welcome back to yet another review exam paper that was recently administered on November the 11th, 2024, which is in fact the second of three assessments that will be administered to my students currently doing or preparing for CSEC exam in 2025. This is the second of three assessments that will be posted here on the channel for this particular term. If you guys would like to have access to the review paper on assessment number 1, a link will be pinned in the description and also pinned in the comments of this video. Now, one of the objectives of me doing videos like this for students wherever you are is objectively to get you guys to improve several aspects of your mathematical ability. Now, I want this paper to be more than just a review paper where I actually go through the answers, but I also want it to be a video that will educate you based on some things that may be preventing you from becoming a more efficient and successful math student. Now, I may end up having some passerbys on the channel, so I want to put it out there, guys, that for the persons who may be watching this video and you've already passed this level, the objective of my videos, or the objective of even starting this channel, is to really give students right across the Caribbean and across the world an equal opportunity to just review back their mistakes that they have made. Now, upon making this video, I would have administered this exam to physical students that attend the institution that I work at, and I would have also administered this exam to my online students. I do not know what the results are for the online and physical students in the evenings, but the results coming in from the students in the day division were a little bit more than alarming. And so throughout this video I will be highlighting mathematical tips that you can add towards your studies, your practice. I'll be highlighting some things that may be preventing you from being more efficient as a student, and also I will be putting out there multiple approaches to not only the thought process of the question but also towards the computation of the questions that you're going to witness in this video. We should be here for maybe about 2 to 2.5 hours. So if you are here, ensure that before you watch this video you have you're in a comfortable space, you have your test papers out, you have your results in front of you, you have some blank papers, pens, pencils, and you're going to just follow me along throughout this video. I want this video to be an extra special one, just so that we can enter into our end of term exam knowing that we have a better chance. Now, some of you guys will have gotten some low grades, and you'd have literally not, pretty much after watching this video, would have been asking yourself, what did I actually do on that exam? I'm going to make this very simple as best as I can here. All right, so let's jump right into the video. But of course, before we do so, do not forget to hit the like button, guys. If you are or have gotten value from my videos, leave your thoughts, opinions, suggestions, ask your questions in the comment section below. And do not forget to subscribe, because of course we're going to be putting out a lot more content throughout the year. All the videos and illustrations will be pinned in the description, will be pinned by a link in the description to previous classes that I've had that is related to what is on this paper here. So check the description or the comments, guys. You will see all the information that you need. All right, so let's jump right into the video. Now, the construction of this exam paper was actually done by yours truly, and the questions that I've constructed are variances of questions that I've taken from past paper exams, 2004 all the way up through to 2024, and I've altered the questions, altered the wording. This is pretty much a self-constructed paper. Now, I did hear a few complaints coming from my students stating that it was a hard exam, it was challenging, but I do in fact think that it is lack of preparation and the ability to comprehend, because of course a lot of the students that I teach are students that are doing what I call a crash course mathematics exam. They're literally trying to do a lot of math problems, understanding the concepts within the space of 7 to 8 months, when it literally requires approximately 2 years. So I cannot blame them when they say that the paper is challenging, because they are in fact taking up a mammoth task of actually taking on this exam within a year. So it's going to require a lot more thinking, it's going to be requiring a lot more practice, objective practice that is, and it's going to, you definitely have to keep up with the pace of learning. But we have done enough talking for about 6 minutes now. Now it's time to jump into the actual computation of the paper here. All right, so let's jump right into it here, guys. Now, starting off here with the instructions. Students, one of your biggest downfalls in this particular paper and in the previous paper and future papers is that you guys are struggling to read the instructions. Math is difficult at the lower level because a lot of you guys have, a little bit of a lapse, a gap in your comprehension skills. So if you're not able to comprehend the questions, then you're going to find it very, very difficult to compute the questions. All right, Csec students, let's jump right into it here. So starting off, it says answer all questions and show all working where necessary. So for question number 1, you're required to evaluate and express your answer as a single fraction. And I have an empty page here, guys, that I've already chopped up here for you. So we have it written down on the screen. All right. Now, for students that are having fractional, problems with, consistently getting your fraction problems right, I will also have a link pinned to a video where you can check that out as well. Do not take it for granted, guys. Fractions is a must-come topic on the exam. It's worth about 3 or 4 marks. Now, let's jump right into the solution here. Starting off with my red. We want to sectionalize the question here, guys. We want to call this section here section A, and we want to call this section B. And so we want to start off by doing our conversions. We want to convert all our mixed fractions to improper. Now you guys have to slow down the pace. You're working against time, but you have to be very efficient with your timing. Now 5 multiplied by 2 here. So 5 multiplied by 2, that's going to give you 10. And 10 plus 3, that's going to give you, say here, 13. So that's going to be 13 over 5. And we're going to subtract, say here, 3 multiplied by 1. And that's going to give us 3. And then 3 plus 2 is going to give us 5. All right. And so we want to convert all the fractions all at once. Okay. So we're going to have 5 multiplied by 1, that is 5. And 5 plus 2, that's going to give us 7 over 5. And we have to remember to square back the expression here. All right. So next then we're going to be going ahead to work out the A section of the problem then. So we're going to therefore then take the 13 over 5 here and bring it down to a different section of your of your answer sheet here, and you're going to work it out separately by finding your LCM. So then here what we have is, to find the LCM, we have to multiply the 2 denominators. So that is 5 multiplied by 3, that's going to give us 15. And then we proceed to divide the LCM by the denominator. So how many groups of 5 can be extracted from 15 when we can get 3 groups of 5 here, or 5 into 15 goes 3 times, and of course 3 into 15 goes 5 times here. 5 groups of 3 can come from 15. Now we proceed to multiply the numerators by the results of the quotient here. So we have 3 multiplied by 13 is 39 All right, and we have 5 multiplied by 5, that's going to give us 25. Okay, so then the final result of the operation at the top of the fraction here is going to be, say here, 14 over 15. All right, and then we're gonna just take a little box here, put a little box around our answer here. All right, let's just put a little box around. Okay, I'm gonna keep that as a little box. Well, it becomes a circle. So sorry guys. All right, so that's our answer for the top section of the problem. All right, now the bottom section of the question, it doesn't require a lot of work. You know, we've already done our conversion, so we can just simply go ahead then and say here that we're going to just use say here 7 over 5. So 7 over 5, and what it means to square, it means that you can either multiply the top by itself, so that is 7 multiplied by 7 over 5 multiplied by 5. All right, that's what 7 squared means. I find a lot of students, well, a few students, you know, forgetting the basic fundamental principles that squaring a number means that you're multiplying the number by itself and not times 2 here. So then that's going to give us 49, and that's going to be over 25 here. All right, so that gives us the answer, say here, for, let's do another block here. Okay, all right, good. So that's the answer for, say here, the bottom section. Now we're going to be taking the answer for the top part of the problem here, which is going to be 14. So that's going to be 14 over 15, and we're going to be dividing that by 49 over 25. And there is this method that we know, you know, in my country we have different, you know, ways of teaching. So one of the methods that we use here is the KFC method, where we basically say that the K stands for to keep the first fraction. We're going to, the C stands for changing the sign to multiplication, and the F stands for flipping the last fraction, so it becomes 25 over 49. Okay, and so therefore then we're going to be looking to reduce our numerators against our denominators here. So we want to look for a number that can actually go cancel diagonally. So it looks as if we can use 5 to cancel into itself, so that goes 1 time here, and 5 into 25 goes 5 times here. And then once again, now we can say 7 into 14 goes 2 times, and 7 into 49 goes 7 times. A few students have also forgot to cancel as well. So then our final result for this problem here is going to be 2 multiplied by 5 is 10, and 1 multiplied by, pardon me here, 2 multiplied by 5 is 10, and 1 multiplied by 7 is 7 here. And let's make sure that we have it right, guys. 7, okay, 7 into 7 7 is 49. Okay, I think we got this, guys. Oh, pardon me, I think it was 14 over 15, because I have an answer sheet here, guys. I have an answer sheet and it's telling me something different. So I think I made an error here when I stated that this would have been 14 over 5. It's actually 14 over 15. So it then means, let me just erase this, forgive me guys for that mental error. All right, so then we'd say 5 into 15 goes 3 times, and then 5 into 25 goes, let's erase this here. Pardon me guys, I think I made a real bad error here. So we can say 5 into 15 goes 3 times, 5 into 25 goes 5 times. So our answer then works out then to be, say here, 2 times 5 is 10, and 3 times 7 is 21. So that there becomes our final answer. All right, what you guys want to do is that you guys always, whenever you're working out a math problem, just like you just saw there, guys, where I made an error, you guys may not have an answer sheet looking at, So you may make the error inadvertently or just by lapse of concentration. But always I encourage students that after you've completed a certain amount of questions, if you have time left over at the end or in the middle, or you feel like you're comfortable with the solution or how you're working at the pace of the paper, always take the time out, guys, to just double check your calculations. Because as math students, the nerves and the pressure and the anxiety will often tend to have you move a little bit faster than you ought to, and you can make small errors like that. But we are safe, and the answer then works out to be 10/21. If you guys are looking at your question paper and your answers, then you should see where you have gone wrong. So take the opportunity, you guys, to use this knowledge and to move forward into your end of term exam, not getting another fraction question incorrect here. All right, now we're going to be moving to a worded question. Then we're going to be moving to a worded problem, and let's go back to our initial paper at the front here, and it says that James is a retail merchant who buys his store products in bulk. Now, during one of his weekly purchases for his store, he spent a total of $37,980, which was inclusive. Let's underline this word, guys. Inclusive of 12% value added tax, or what we say is GCT, or we just simply say sales tax. Now, we are required to calculate the value added tax amount that he paid on the purchases he made, and of course in part 2 here, after reselling the goods he bought, he acquired a total of $46,240 revenue. Express his profit or his loss as a percentage of the total spent. Now, what I find most of the times with students that are doing crash course exams is the comprehension of the questions. They often tend to complain a little bit about not liking worded problems, but your English language, your comprehension skills is really the definitive factor in how exactly it is that you will get these questions incorrect. If you have very low comprehension skills, if you aren't understanding what the question is asking you, knowing a formula is going to be quite futile. So you want to ensure that you work on your comprehension skills here. Now, with this type of question, let's go back to our empty page here and see what we can set up, what we can carve out here, guys, for the solution for this question. Okay. Okay, so James is a retail merchant who buys his store products in bulks during one of his weekly purchases. Okay, so therefore he spent a total of $37,980, which is inclusive of VAT. Now, as I've told many of my students, that the catch with this question is often where students often say 12% over 100 and multiply it by the actual value, which is 37,980. Now, when you do that, what you're actually doing is that you're actually finding the tax percentage, or you're finding the percentage of tax that is already in the amount of money there. So that keyword inclusive is the trap in the question here. You guys have to stop falling for that. Stop falling for, often just diving into just finding the percentage. And I've also seen some errors where students are dividing numerical values by percentages. It's just a little bit all over the place, guys. So you just got to get hold of the understanding of the question here. So what you want to look at is, say here, there's a couple of ways to do this question. And I can safely say that a student by the name of Kevon that I'm teaching, he taught me a method. He showed me a method of thinking, and I also have a student by the name of Jodine Bird. She also was doing some research on how to do percentage, and she pounced upon a method. So I'm going to show you those 3 methods to getting these answers here, guys. Now, my way of working the problem is simply to state that the original, for me, I always start out by saying the original price of anything at all. Anything that you're buying, the original price is always equal to 100 That's where I always start my problem. All right. And when we talk about original price, we're looking at the price that is exclusive of VAT or GCT or sales tax. I call it the exclusive price. Now, once I know this information, I know that the tax has already been included in the cost that I'm actually looking at, which is 37,980. So that's 37,980. I know that the tax is already in it. So it simply means then that if I take the 12% here, pardon me guys, if I take the 12% here and I add it to the 100, then that's going to give me 112%. So I know that the price that the price or the amount that was spent by James here is 112% is actually equal to the 37,980. Whatever he spent, it had the tax in it already. So that's why I added the 12%. Now, if I use direct proportion here, I can find what is known as the SP. And the SP is the single proportion, or what I call one share. So 1% will be equal to 37,980 divided by 112. And so if that gives me 1%, so 1% then is going to be equal to, and we can grab our calculator. Let me a second here, guys. I could pull the calculator up on the screen, but it's a very simple math. So let me grab my calculator here, guys, just a second. Okay, got. So we have 37,980 divided by 112. That's going to give us $339. And well, it says 107, so that's 1 cent. All right, so that's 11 cents. Okay, now since I'm looking for the original price, guys, it's going to be 100 of those 1%. So it's 100 multiplied by 339.11 cents. All right, and that's going to give us, say here, $33,911 there. And that is your actual answer for the question. So that is option number 1 of approaching this question. All right, you guys got to practice to know. I call these questions reverse questions, when you're going backwards as opposed to going forward. All right, I do apologize if you think I'm being a little bit talkative, but this was a paper that I felt was quite balanced to an extent, but the review coming from the students at the time of making this video was it was a little bit of a shocker, because I found that a lot of persons were complaining that the paper was challenging, they weren't prepared, they didn't practice, so I really want to make this more than just a review paper. I want to actually make it into a conversation. I want to make it into a class. So if you're watching this video, guys, it's going to be lengthy. You can watch it in parts, but it's more for me here, guys, to work on your thought process, guys. A lot of my students are a little bit disadvantaged with the comprehension skills. All right, let's look at another option of working out this very same question here. All right, everybody thinks a little bit different. Everybody learns the math a different way. Now, not sure where Jodine got the method. She did disclose to me that she was watching another YouTube video, so I want to share that method with you as well. What Jodine did is that she added 12 to 100 and she got 112%. So what she did is that she found 12% of the amount that includes the 12% already. So she found 12% divided by 112. She found 12% of the inclusive value. So 12% of 112, and she multiplied it by 37,980. And just to pull up my calculator here, guys, just a sec. Let's pull up our calculator. Just a sec, guys. Okay, there we go. So now we have, say here, 12 divided by 112, and we times that by 37,980. Surprise, we got, okay, so 12 divided by 112 multiplied by 37,980, we got $4,069.29. Let's write that down, guys. $4,069.29. So that's $4,069.29. All right, so this approach that Jodine took, it found the actual tax immediately, right? Which is exactly what the question asked for. It says calculate the VAT amount he paid on the purchase. So that will give us our answer immediately. All right, now if we wanted to say, for example, know what the price was before the tax, because it does tend to ask us questions like that. I think it says, right, it didn't ask us for that, but should it ask us for that, we could say 37,980 minus 4,069.29 cents. Then if we grab our calculator here, and I hope you have your calculators in hand as well, guys. If you go ahead and you say 37,980 minus 4,069.29, you'll get the approximate answer that we got earlier, which is 33,910.71. So it's going to be relatively close to the answer that we got earlier. And as a disclaimer, guys, I think that in method 1 where I did it, I actually did not do the subtraction. So this is the answer that we're actually looking for, $4,069.29, because it did say that they wanted the VAT amount. In method 1, I forgot, guys. I just realized that I forgot to do the subtraction. But had you done the subtraction, you can double check that for me, guys. Let me know if you got an answer very close to $4,069.29 there. All right, so that is method 2. Let me know in the comments, guys, if you like that method. In fact, let me know in the comments what method it is you used and why you used that method, if it was efficient. Now, very interesting, I didn't even think of this. All right, and it's always good, because I'm a teacher, I'm an instructor that learns from my students. Now, I had a student by the name of Kevon, and what he did is that as opposed to doing what we did in method 1 and method 2, what he did is that he did a subtraction instead. So he said 100 minus 12, and that gave him 88%. And so what he did is that he said 88 over 100, and he multiplied it by 37,980. Now let's grab our calculator here, guys, for 88 over 100. So let's do that. Let's see what comes up on the screen. So 88 over 100 multiplied by 37,980. And look what we got, guys. We got an answer of 33,422.4. So we're getting off answers a little bit. All right, we're getting answers that are close to what we had stated. 33,422.40. Let's write that down. So that's 33,422. Is that what we had, guys? Double check on that. 33,422.40. Okay. 0.40. All right, and if we go ahead then and we were to subtract that from 37,980, so that's going to it's going to get a negative, guys, but we get the idea. 37,980. You realize that we got an answer 4,557.60. So you can see that we're getting variances of answers here. I think I'm just going to trust method 1. I may be miscalculating somewhere, but we're getting answers that are a little bit off. You know, the answer that we got was 4,069 earlier. This answer here is 4,557.6. Not really feeling that method. Feel like that method's a little bit off. I'm not sure, guys. Let me know your thoughts in the comments. If I made an error, please let me know in the comments as well. But I'm just going to be sticking with method 1, where I use that direct proportional approach. Because when you reverse the formula, then I get the answer, and my answer is always close to my original by a couple cents. It's off by a couple cents. So I'm going to be sticking with method 1, guys. But if you have any other method, please let me know in the comments as well. All right. So a little bit of a lengthy explanation there, guys, but I hope it opens up your mind to approaching that question in the future. If you are watching this video and you are enjoying and you are getting the necessary review that you require, hit that like button. And let's get into part 2. After reselling the goods that he bought, let's go back to our page here, guys. So after reselling the goods that he bought, he acquired a total of 46,240. We are to express his profit or loss as a percentage of the total spent. Now, our initial answer that we had here, let's go to an empty page here, guys. All right, so let's write down a couple of stuff. All right, let's write down the answer that we got for method 1. Okay, so when we did our calculation, our solution was, okay, let's run back through that again. So it's going to be 37,000. So what we did is that we divided 37,980 by 112. And when we did that, we got, let's see here, 37,980 divided by 112. We got 39. This is method 1 that I'm reviewing, guys. 39.10. And then we multiply that by 100. So this is actually what we would have paid prior to the tax. 33,910. That's what I got for method 1. All right. Now, having that information now, it would mean then that 46,000 was collected. What was it? I think it was 46,240. And what was spent was 37,980. So the profit gained here, okay, so that's going to be 46,240 divided by, well, not divide, 46,240 minus 37,980, and that's going to give us, I think I made an error, guys, hold on, give me a sec, divided by 37,980, getting some funny numbers here, my calculator may be malfunctioning, minus 37,980. Okay, so I'm getting $8,260. All right. So then to express this as a percentage, we're going to have 8,260, which is a profit, divided by what was spent, 37,980. So we're going to divide that by 37,980, and we're going to times that by 100%. So we would have gotten here 21. Well, in fact, rounded off, we get approximately 22%. All right. So that's how you would actually do the calculation for that problem there. Okay. But you guys may have other approaches as well. And if you're getting the same answer as I am getting, then it means that your approach is mathematically acceptable. All right. I didn't really trust method 2 or method 3. I may have made an inadvertent error during my calculations because I'm so focused on making the video. But if I have, let me know in the comments as well, guys. And I will also do a review in the editing process, and I will leave my errors in the comment section as well. All right, so let's dive into part C of the paper. Now, part C stated that we should find the exact value of 125 divided by 121 raised to the power of a half, subtract 2 to the negative 5. And this particular question as well, guys, also has a couple of approaches. In fact, I found that quite a few of my students took up an approach that I was not aware that they knew. So they took a surge approach to the question as well, but they got the answer and they got the marks. So let's look at how I would encourage you to do this question in an actual exam here. Now, I often encourage my students to just get straight to the point. You're working against time, so use up your calculator as best as you can. Now, you can just go right ahead, guys, and tap into your calculator. I have a physical calculator in my hand, so I can go ahead and say 125. I'm going to be using the Pemdas rule here, and the Pemdas rule states that I should work out what is in the bracket first. So I'm going to have 125 divided by 121, and that should give me an answer here of 1.033. It's a lot more digits, but I'm just going to use about 3 digits. What comes after this is a 0, so I'm just going to use 1.033. I'm going to raise that back to the power of a half, and I'm also going to go on my calculator here, and I'm going to type in 2 raised to the power. So I'm going to raise, so 2, I'm going to press my power button, that is the X to the Y button, or it's an arrow button. You guys should be familiar with your power button. And I'm going to open a bracket, and I'm going to raise it to the -5. So I'm going to have -5, and then I'm going to press here equal. I will get 0.031. Okay, all right, so that's how I'm going to approach it here. And then now I'm going to go on my calculator again. I'm going to type 1.033. I'm going to also press my power button again as well. I'm going to open a bracket, and that's going to be 1 divided by 2, close my bracket and press equal. I end up with 1.016. all right, I think what comes after this is a 3, so I can use 3 decimal places. That's fine, and that's 0.031. This is if you're using the calculator approach, guys. Now if I go ahead and I subtract 0.031, I will end up with, oops, I think I made an error here, guys. 1.016 subtract 0.031, I get, and that's equal to 0.985. All right, that is the calculator approach, and this is the approach that I want to take because following up the question, if we were to go back to our initial page here, it asks us to, I believe it asks us to, after the calculation, we are to write the solution correct to the following approximations. So that alone, this alone tells me that I need my answer to be in a decimal form. All right, so we're gonna get the answers up and running here, guys, in a second. So we want to round off, say here, the first question did state that we should write the answer exactly. So this would be my exact answer. Let's put a little green box around this here. All right, that's my answer. That's my exact answer. Then it said I should use my answer then to round it off to 2 dp. So I'm going to say here 0.985. And when we talk about decimal places, students, we're talking about the digits that comes after the point. So here I'm just going to be drawing a line behind the second digit behind the point, and that's the 8. I will then draw a line here, an arrow, and I will check the digit that comes right after the 8. That digit is 5. So whenever the digit that comes after the vertical line is greater than or equal to 5, we will add 1 to the digit or the number before. So this is going to be 98 plus 1, which is 99, or 8 plus 1, which is 9. So that's 0.99. That's the rounding off for that number. That is to 2 decimal places. Now we're of course going to go ahead then and use that same number, 0.98. And this time they want us to round it off to 3 significant figures. 0.985, 3 significant figures. Fun fact is that it is already to 3 significant figures. It is already, guys, to 3 significant figures. So we rounded this off earlier. We got 0.99. And this number here, it is already written to 3 significant figures. So we're going to leave it as that right there. All right, 0.985. Let's put a box around this. Beautiful. So that's for part 2. And then for part 3, we need to write our exact answer in standard form to 1 dp. So we're going to take that number again, 0.95985, pardon me guys. And when it comes to standard form, what we want to do is that we want to move our decimal point into the direction of the first non-zero digit. And so we're going to move our point right behind the 9, or in between the 9 and the 8, so to speak. So we're going to do this here. Oops. Oh, it's drawing me a circle, guys. Alright, so we're going to put the point there, and we should end up with we're going to end up with, pardon me here, guys. Oops. So we're going to, when we move the point between the 9 and the 8, we're going to have 9.8. Standard form is going to be times 10. We're going to raise that to the power of 1. Okay, I think I'm having some typing error here. So 10 to the, so we jump one place to the right, so that's negative 1. All right, so 9.8 times 10 to the negative 1 here. All right, if you guys would like to check out my approximation video, I don't remember if I have an up close personal video with approximation. If you guys would like me to do one specifically for this, I can just leave it in the comments. But I think I have another video that I can source where if you guys are having a little bit, or you need a little bit more clarity on approximation of numbers to decimal places, significant figures, and our standard form, check the description box below, guys. If you don't see it, please let me know in the comments, and I will directly message you and pin you the link. All right, so bonus questions is what I call those type of questions, guys. We got to tap into those and get it. We're not going to tap into other methods to work this question, because for the purpose of this video, I want to keep it centered around the way how I have been teaching the students. All right, beautiful. Let's then go back. Well, in fact, let's move on, say here, to question 2. We are 45 minutes in. Remember, guys, that at the point of watching this video, this is not just a review paper, but it's a paper to help you to develop your comprehension skills, to help you to interpret the questions better, to look at multiple routes, multiple ways to solve the questions. And I hope you guys have your test papers in front of you, so you are seeing where you went wrong, because that's the only way you can improve. All right, remember, crash course mathematics is difficult and it requires a lot of practice, objective practice, that is. All right, so let's jump into question number 2. A carpenter works at a furniture manufacturing company and he's paid a basic rate of $34.15 for a basic week of 50 hours. Now, he's paid at time and a half rate for any overtime that he works. Question 1 says here that we should calculate for the carpenter his basic monthly salary here. Now, there's something that I want to highlight, and I did this on purpose, and I'm not certain if my students picked up on this, but I want to also point this out. Csec does this quite a bit as well. The teacher or the instructor that the instructors that constructed the paper, they have what is called non-verbal communication, and what they do is that they verbally communicate with you by putting certain words in italics or in bold. So if you notice here that I have bold the word basic rate, I've bold the word basic week, and I've also bold the word or the compound words time and a half, and I've also bolded, say here, the numerical value of the hourly rate, and I also bolded the 50 hours. These particular numbers, what I'm non-verbally trying to communicate with you here is that these are the keywords that will potentially lead you to the solution. Now, for some students who have a challenge in remembering formulas, you've got to try to tap into the common sense aspect of the question, because sometimes a formula can mislead you as well. Now, we're looking at someone who is working 50 hours a week and they're being paid $34.15 34.15 for each of those 50 hours. And we need to calculate their basic month. Then this simply means then that I would have had to calculate the carpenter's basic week or basic wage, pardon me. I would have had to calculate the carpenter's basic wage. And then if I can be able to calculate the carpenter's basic wage, I can simply multiply the result by 4. So basic wage formula, if you guys are familiar with this, is equal to basic week multiplied by basic rate. And I often encourage my students to use what I call the GD rule. All right, it's the GR rule, pardon me, not the GD rule, but the GR rule. And this GR rule is a technique that I use because I'm teaching the course in reverse, and a lot of the basic principles students do not have in the bag. So you use what is called the golden rule. And so with the golden rule, you want to start off with always writing down a formula. The formula tells you what to do. Now in this question, we are told that the basic week is 40 hours. So we would therefore take 50 hours, pardon me. We will put the 50 underneath the variable that represents basic week. And they also told us that the basic rate is $34 and say here 15 cents. Pardon me, guys. Now, the purpose of the golden rule here, or the purpose of writing down a formula, is that it takes the guesswork out of the mathematics. Now, of course, advanced students may not necessarily do this. They will instinctively just know that they have to multiply. If you're at that level, then by all means you go right ahead and do that. Now when you multiply, say here 50 multiplied by 34.50, so that's 50 multiplied by 34.15, then we end up with $1,707. all right, and that's going to be $1,707.50. Now, please bear in mind, guys, that this is just the basic wage, but the question specifically asks for the basic month. So, how many weeks make a month? Then you will find here that we will have to multiply that result here by, say here, 4. And so by multiplying that value there by 4, we end up with $6,830. all right. So if you are watching this video and you recognize that you have left off the 4, then therefore you can see that it's not that the math is difficult or you cannot remember the formula. It is the interpretation of the question or the comprehension of the questions that is literally, and sometimes you guys are moving a hair too fast. So slow down your thought process, guys. Read the questions carefully, interpret, and then you begin your computation. All right, so that is it for that question. Then now for the next part of this question, I believe that when I was writing the paper, I'm going to take accountability for this because I think my English language failed me here, guys. Right, I'm not an English teacher. I just have basic skills that I can write a question, because my exam papers are self-designed. They are not copied. They are copied and pasted from any past paper questions. I literally designed these questions on spot. Now, there was some high demand of furniture it should have been to be made for a school in which he was required to do 1 additional hour each week for that month, starting at 3 hours in the week. It's starting at 3 hours in week 1. We have to calculate his overtime wage for that month. Now, what I was trying to convey to the students is that in week 1 of overtime, he would have started with 3 hours working overtime. And then when I said here that he's required to do 1 additional hour each week, it kind of comes off that in week 1, he's going to start with 3. Week 2, he's going to do another 1. So that's going to be 4 hours in total. Then in week 5, he's going to do another 1. That's going to be 6 hours. And then in week 4, he's going to do another one, which is going to be 7 hours. So I saw a few students interpreted the question that way, and I took accountability based on how it was structured, because I think that interpretation is somewhat valid based on what I saw or based on what I wrote on the paper. So if you did that, I would have given you full marks for that. But in fact, what I was trying to convey is that, and let's go to our blank page here. What I was trying to convey in this particular paper here is that I wanted to convey that in week 1, three hours was done. And so I wanted to convey the fact that in week 2, he would also do another 3 hours plus 1. That's what I was trying to get across to the students. And in week 3, he would have done yet again another 3 hours plus, again, this is also another way of interpreting it. So in week 3, I would have wanted him to do 4 hours plus 1, and then in week 4 he would have done 5 hours plus 1. So that's what I was trying to convey, and quite a few of my students did complain about the structure or the wording of the question. So I took accountability, and I definitely need to work on, getting the questions to be structured a bit better. All right. So this is what I was trying to convey. So he would have done 3 hours in week 1, 4 hours in week 2, 5 hours in week 3, 6 hours in week 4. And so the total amount of overtime hours there would have been 18. That's 6 plus 5 is 11. 11 plus 4 is 15. 15 plus 3 is 18. So that's what I was trying to convey, ladies and gentlemen. But again, let me know in the comments if your students are a little bit better at the English language than I am. Let me know in the comments if I worded it correctly. Can it be interpreted in the way that I had intended, or did you guys have a different interpretation? Let me know in the comments, guys. All right, but we're gonna be sticking with my initial what I initially wanted to convey, which is what is on screen here. All right, so forgive me, guys, if I cause you to mess up that question then. Okay, let's see here. Let's do some. So it's 18 hours, so let's just erase all of here. So we just did that calculation based on what I was trying to convey. So 18 hours was done overtime. So 18 hours was done overtime. And so we know that each hour, regardless of whether it be overtime or regular hours, would have been 18 hours multiplied by 34.15. Now earlier, there was an indication in one of the questions that stated that, and here we have it, that any time that is worked, or he's paid at, there it is, guys, time and a half for any overtime that he works. So for any overtime that he works here, he's going to be paid at time and a half. So that's going to be 1.5. In fact, I saw a few students writing down 0.5. That was quite interesting as well. But nevertheless here, it is time and a half, so that's 1.5. So we're going to have, say here, 18 multiplied by 34.15 multiplied by 1.5. And we end up with $922.05. All right? There. So that would have been the overtime wage that he got. And that was what the question had asked us for. It says, calculate his overtime wage for that month. So that ends that question. All right. So for those of you guys who would have had a slightly different interpretation based on the fact that I think that I may have messed up in terms of the construction of the question, if your answer is somewhat valid and has a reasonable interpretation, I will award you with the marks. All right, so we're learning each day. Even as a teacher, we're learning each day, because I write my own papers. Yeah, okay. All right, good. So we're going to be moving on to the final part of that question. It's a little bit chopped up here. It did say at the end right here that we should hence determine the carpenter's gross monthly income for that particular month, and it's just a mark, so it doesn't require much really. All right, so the gross month then obviously would have actually been just a second here, guys. So the gross month would have been the $6,830. So it would have been the $6,830 plus the 922.05. So we have 6,830 plus 922.05. We end up with 7,500 and 7,000. Pardon me. 752.05. All right, so that is your final answer for that question. All right, so like I said, guys, I do apologize for the structure of that question. My initial thought that I want to convey, I did not think it was structured properly, but we're going to be learning from our own mistakes then and there. All right, good. So we are approaching an hour into the video and we have not yet gone through, well, we are just approaching half of the paper. Remember, guys, as I stated earlier, if you're watching at this point in the video, this video is more than just a review paper. It is an opportunity for us to have a class, walk through the thought process step by step, and help students who may have missed out on certain sessions to actually have an understanding. And if this type of teaching is helpful to you, ensure that you guys do not leave this video without hitting the like button here. All right, and of course subscribe. Question number 3. We are required to expand and simplify expressions below. 1.7x squared y minus 3xy squared minus 2.3x squared y plus 2.8xy squared. And for part 2, we are asked also to do 15a raised to the negative 2x raised to the half divided by 3a to the quarter x raised to negative 3 multiplied by 4a to the negative a third x. All right, now I do have a full class on this particular video here. This particular question, I have a full tutorial class. In fact, I have 2 classes. One in which I did a Sunday extra class with my students, about 12 or 13 of you guys. You can check that video out. And I also have a live class that I posted on my channel talking about addition and subtraction of algebraic terms, as well as the multiplication and division using the first 2 laws of indices. So if you guys do not get what is explained in this video, of course, use the opportunity to check out those other links. It's a much slower pace and much more interaction with students in the live class. Now I've already transferred the working out here on the other sheet. So let's go all the way over here and see what we can find here. Alright, so we are adding and subtracting algebraic terms, and the basic rule is do not interfere with the powers of the variables. Do not interfere with the powers of the variables. All your focus is going to be on, say here, the numerical values at the front. So we're going to be using the variables to group, but we're going to be adding or subtracting the coefficients of the numbers. So here what we're looking at is looking for any term that may be an x squared y. So we're looking in the expression for another x squared y, and we can find that there's an x squared y here. So those two numbers will be grouped. Let's do that right now. We have 1.7 x squared y, and we have minus 2.3 again x squared y. All right, and then of course we're going to have, say here, let's grab a different color marker. Let's do purple. Okay, all right, and so for purple we're looking for xy squared. So we have a xy squared here. Pardon me guys, let me ensure that I use a color. I'm trying to color code the teaching here guys so you guys can follow. Let's use green. All right, so we have x squared. Okay, we have x squared y. So we have xy squared, pardon me, do apologize guys. We have xy squared, and we're looking for the other term that is xy squared as well, which is that one over there. So we're gonna have minus 3xy squared, and we're gonna have plus 2.8 xy squared. All right, now we have that. We have everything grouped and according to colors. Now we can basically go ahead and jump onto our calculator, and we're going to type exactly what we're looking at. Looking at the coefficients for the red, we have 1.7, and we're going to take away 2.3, and we end up with, say here, negative 0.6 x squared y. All right, and then finally then we're going to go ahead and do the other two. Now what a lot of students I find do is that they completely forget that this minus sign goes with the 3, so they often tend to type in 3 plus 2.8, and then they will write down negative 5.8. If you're that guilty student, then you know that that number you have to involve the sign as well. So you want to go ahead and type negative 3 on the screen plus 2.8, and as opposed to getting negative 5.8, you will find here that you get negative 0.2 xy squared. All right, and that there is your solution to the question. All right, so just please remember guys that when you're adding and subtracting algebraic terms, the objective here is to group like terms based on the type of base that it has, and then you will of course add or subtract the appropriate coefficients as written on the paper there. All right, beautiful, really nice question there. 2 marks, really nice, 2 healthy marks there that you can actually cut down. Now we have this particular question here, and it does look like a little bit of a Chinese math based on how I'm writing. All right, based on how I'm writing guys. Of course, let me just take the opportunity before jumping into this question guys. You guys can follow me on social media platforms. You can follow me on TikTok, where you'll see students working questions, students that are currently preparing for exams are confidently working out these problems in the live classes. You can follow me also on Instagram, where I post the successful students that are attaining high averages, that are doing pretty well, that are getting awards monthly after these exams. Of course, you can also follow me on Facebook. You can follow me also here on YouTube, and if you would like to be a part of the class, you can make contact with me in my contact details that is pinned also in the description of this video. All right, if you guys would like to join my online class, wherever you are, whenever you're watching this video, you can direct message me on any one of my platforms to join the live class to get the experience being taught by the Csec mathematics guru. All right, so here we go. 15a raised to the negative 2 x to the half divided by 3a to the quarter x to the negative 3 multiplied by 4a to the negative third x. You guys can check out the Sunday class that was recently posted on the channel. It's a review class that was done prior to this exam. It also has some examples as well in that. So let's dive into this. The key in this question, guys, is to be as organized as possible. If it's too jumbled up, you guys are going to make a mess of the question. So we want to take out the 15 here, and we want to divide it then by the say here 3, and we want to multiply it, say here, by the 4. Okay, and then what we want to do now is that we want to group all the A's together. So we want to have an A here, we have an A here, and we have an A here and an A here. So all the bases are the same. So according to law of indices number 1, when we are multiplying, we add, and when we are dividing, we subtract. So we are dividing the first power, so we're dividing the power of the first A, and we're dividing it by the power of the second A. So because we are dividing, we're going to subtract. So I'm going to be using a different color here for the subtract. So this is a subtraction sign that is related to the division sign, and then we're going to have here, say, a quarter here. Okay, and then of course we're going to move across to the next A over here, which is negative a third. But because we are multiplying, then we're going to be adding, say here, the next power. So we're going to be adding, say here, a third. We're going to be adding negative a third, pardon me. We're going to be adding negative a third. All right, we're going to hold on to that for a second. I'll be right back. We're going to go back to B. Is it B? Or I think it's X. Pardon me, guys. Moving a little bit too fast here. So we're going to take all the X's then, and we're going to start the process again. So the power of the first X, which is this one here, the power of that first X here is going to be, say here, half. And once again, because we are dividing, we're going to subtract the power of the next A, which is going to be a quarter. I'm trying to color code my teaching here, guys, for you, so it's easy for you guys to follow. Quarter. And then of course over here I'm going to be multiplying, so I'm going to be adding. All right, so we have the first power is a half, the second power is, I think I made an error, guys. You guys might have seen that. Let's go again. Let's slow it down. The first power of the X is a half. We are dividing, so we're going to be subtracting. And let's look at the power of the second X. It's negative 3, so we're going to subtract negative 3. And then of course we're going to be multiplying now, so we're going to be adding the next power. And the next power of the next X. You don't see a power attached to the X, but all my students, or all of you guys, should know that there's an understood power of 1. Alright? Alright, so a little bit of a trick there, guys. We just got to focus on what we're looking at, and then we should be okay. Now we're going to go ahead and proceed to find the LCM, because we have a third as a fraction, we have a quarter as a fraction. We're going to just simply put this over 1, and we're going to find the LCM here. Okay, so the LCM here is going to be 1 multiplied by 4, which is 4 multiplied by 3, which is 12. So now we proceed to say 1 into 12 goes 12 times. And we're going to have 4 into 12 goes 3 times. And then we're going to have 3 into 12 goes 4 times. So now we have 12 multiplied by negative 2. That's going to give us negative 24. 3 multiplied by negative 1. That's going to give us negative 3. And 4 multiplied by negative 1. That's going to give us negative 4. Alright, let's hold on to that in a second. Let's go ahead and find the LCM for this fraction over here. We have a half, then we have negative 3. Put that over 1. Put this also over 1 as well. Because since we have a half as a fraction, we turn everybody into a fraction. So here the LCM here is 2. That's 2 times 1 times 1. 2 into 2 goes 1 time. Alright, so the bottom 2 here into this 2, 1 time. Then we have 1 into 2 goes 2 times at the top. And 1 into 2 goes 2 times as well at the top. Alright, so now we end up with 1 times 1 is 1. And then we have a double negative here. We have a green negative sign with a red negative sign. So the two negatives become a plus. 3 times 2 is 6. And we also have another plus here. And that's going to be 2 times 1 is 2. Okay? So once we can successfully take about 5 minutes and just kind of slowly going through the steps and making sure that everything is right, we can write our final result here. Our final result is going to be 15 divided by 3 is 5. And 5 multiplied by 4 is 20. And then we're going to have the A written here, and then we're going to work out what is on the line. Negative 24 minus 3, that's negative 27. Negative 27 minus 4, that's going to be equal to negative 31 over 12. And then we have X. 1 plus 6 is 7. 7 plus 2 is 9 over 2. Right, and that is your final answer. Okay, all right, so let's put a little box around this. That is our final solution, ladies and gentlemen. All right, so if you guys would like a little bit more slower process, you can either rewind or, you know, bring back the buffer and rewatch the steps again. Double check, make sure that you have your paper in your hand so you can look at what you did or what you were supposed to do, and you can make the corrections on a separate paper, or you can make the corrections on your question paper. And once you've completed that, you want to fold this paper up, guys, and slide it into your book or slide it into your study materials. And so when you go back to this paper, you'll know exactly what you should have done here. All right, you want to take a more objective approach towards solving math questions, guys. Definitely that's something that we want to really tap into, because in order for you to be successful in a crash course exam, you want to ensure that you guys have all the tools and resources available. Now we're going to be moving to the distributive aspect of the question. Here we have 5 subtract 2x open bracket 3 minus 5x close bracket plus 7 minus open bracket x squared minus 5x here. Now we're expected to simplify this to its lowest term. Now this question was purposely designed to test the student's ability of recollection. And one of the things that I emphasize both on my online class and in my physical class is the importance of remembering what you can or cannot do when it comes to algebraic terms. And one of the things that we emphasize on is the fact that we are not allowed to subtract or add terms that are unlike. If you guys would like to see the unlike video, like versus unlike video, I will pin also a link to that specific chopped up video where you can look at how to recognize when a term is like or unlike. So that is also pinned in the description box below. Now say here we have 5 take away 2x. Two reasons why we're not allowed to do that. Number one, 2x is an algebraic expression, 5 is a numerical constant, so we cannot subtract those. And number two, you would also be breaking the rule of Pemdas as well, because you're not allowed to subtract before you multiply, and distribution is a form of multiplication. So in this case then, you have to bring down the 5 and you have to distribute, say here, pardon me, you're gonna have to distribute the negative 2x inside the bracket. So we have negative 2x times 3, and we have negative, whoops, and we have negative 2x times negative 5x. Then we're going to go ahead now and check to see on the other side. It's a very tricky section of the problem right here, because some students might accidentally distribute the 7 inside the bracket, which obviously would have been a grave error, because there is a understood 1 that is in front of the bracket here. And I set that question up because students often make that error of distributing from too far. So you're going to go ahead then and just understand that there's a 1 there. You're going to be distributing the negative sign here. Believe it or not, guys, these are the small little things that you overlook when it comes to solving these questions here. All right, so let's set that up. Okay, so we're going to go ahead and do our distribution. So we bring down the 5 and we see negative 2 times 3, that's negative 6, and we bring down back the x, so negative 2x times 3, that's negative 6x, and we have negative times negative is a positive, so the negative sign outside multiplies the negative sign in front of the 5x inside, that gives us positive. 2 times 5 is 10, and the x times x gives us x squared. Alright, then we move along. We're going to bring down the 7 as we had discussed earlier, and we're going to be distributing the negative 1. Again, you must be asking, or you might be wondering, I did not know that was a negative 1, or I don't remember that was a negative 1. You don't have to really think it's negative 1, just know that you're distributing the negative sign. So that's negative times x squared, that's negative x squared, and negative multiplied by negative is a positive. And of course we know that the 5x is going to come back because 1 times 5x is 5x. Now once you're able to kind of get through that part, then you're going to go back to your fundamental algebraic skills of grouping like terms. Now we like to write our answer in descending powers, even though it doesn't matter the order in which the answer is written down, but we like to write, as mathematicians, we like to write our answer in descending powers. So we like to write the highest power first, and then we're going to descend until we reach the constant. So I'm going to group 10x squared with x squared. So we're going to move that negative x squared beside the 10x squared. Then we're going to have negative 6x. Do not forget to bring the negative sign that is in front of the 6x, guys. Plus 5x. And then we're going to end up with positive 5, which is at the front here. And then bring down the positive 7 here. Alright, and then say 10x squared minus x squared is 9x squared. Then we're going to have minus 6x plus 5x. That's going to give us negative x. Just go ahead and type on your calculator. Negative 6 plus 5, negative 1. Remember, we do not interfere with the powers of the variables when we are adding and or subtracting. The only time we interfere with the powers is when we are multiplying and dividing. All right, and then finally 5 plus 7 here is 12. All right, and so this becomes our final result. Let's put a little black box around this here. Beautiful, that's our answer. All right, so thumbs up to the students that actually pounced on this question and collected your 3 juicy marks there. Let's move right along now to question 4 of the paper. All right, let's go back to page 1. Let's have a look at the question. Okay, so we're going to go, okay, so that page is finished. Let me try to see if I can find that page here. Gotcha, there it is. So for question 4 then, here we have it. Okay, beautiful. So question 4, let's zoom out a little bit. Okay, gotcha, there we have it. So Clark is an employee at a sales marketing firm that sells scented products to customers across the island. His job allows him to earn a commission, and I must pause here for a second. I did in fact let my students know that during the typing of the paper, I inadvertently left out the percentage at which Clark receives his commission. So you can see I've indicated right there that it should have been 13%. So all my students are in fact aware that the missing percentage is 13. So let's continue. So his job allows him to earn a commission of 13% on the total sales he is able to make for that month, and that is going to be in addition to his monthly salary. Now, during a specific month, Clark made a significant number of sales that allowed him to receive an unusual monthly check, and that should have actually been CHEQUE, receives an unusual monthly check of 12,780, which is inclusive, there is that word again, tricky word, inclusive of 3,280 of commission earnings. All right. Now the complaints that I got from a few of the students, because I think that a lot of my students, they are familiar with what I refer to as the GR, the golden rule, the GR method, the golden rule, where we always start by writing down a formula. Always practice to have your formulas in your mind, guys. I cannot emphasize on how important it is, because it does take the guesswork out of mathematics. You won't have to wonder if you should add, multiply, subtract, or divide. The formula will reveal what needs to be done. So here, what we have then is a bunch of wordy stuff. Let's highlight the most important aspect of the question. We know that the unusual monthly check is 12,780. And we also know that, based on this comprehending the question, that inside of that 12,780 includes some commission earnings. So which means that the 12,780 is not his usual monthly check. It's unusual because it had some extra income in it. So if we can remove the extra income from the unusual monthly check, then that would, common sense means that you're going to get the usual check, and we most likely will refer to our usual check as our monthly check or our monthly salary. And that pretty much is the interpretation behind finding answer number 1. Determine Clark's monthly salary. We're just going to basically subtract the commission from the unusual check. Let's go to an empty page here and figure that out as well. All right. So let's see here. And I like to write stuff, not for the purpose of the examiner, but for my own purpose here. I like to write stuff. So I like to write down that the monthly check in this case, you don't have a general formula for it in this context, but the monthly check based on the information provided is going to be the unusual minus the commission. So the unusual is 12,900. Is it 12,780? I think that's, yeah, 12,780 minus 3,280. I believe that's what it is. Let me just double check on that. 12,780, correct, minus 3,280. So if we subtract those two, we will end up, say here, with $9,500. All right. And that's why it's only worth 1 mark, ladies and gentlemen, because it's a basic subtraction. 1 mark just for the interpretation and the calculation. All right, no problems with that. Now we went on then to ask to determine the total sales. Let me just pull that back up on screen for you. It did go ahead to ask us to determine, it says here, determine the total sales made by Clark for that month. Remember, advanced students will automatically know that you are to divide the 3,280 by the percentage of 13. But for the students who are not so advanced, then you need to use the GR method, the golden rule method. And that is where we write down that commission commission, don't forget to write commission, is equal to X% over 100 multiplied by total sales. We're going to abbreviate total sales as TS. All right. Now, with this said, reading the question earlier, it stated that the 12,780 was inclusive of 3,280 of commission earnings. So I can therefore go ahead and put the 3,280 under the commission variable, and the percent at which the commission was paid is 13%. So that's 13 over 100 multiplied by TS. Now automatically then when you look at the formula, you'll realize that there's a constant, there's a $3,280 constant on the left, so there's not much math to do there on the left. But on the right we see where we can in fact divide 13 by 100. So we're going to continue the formula by writing down that 3,280 is in fact equal to 13 divided by 100. If you do that on your calculator, guys, you will get 0.13, and that will be multiplied again by TS. So we're really just letting the formula guide us through the steps, guys. We're letting the formula guide us through the steps. Right? We're writing everything line by line. So now, because the total sales is attached to the 0.13 by multiplication, then the opposite of multiplication is to divide. So we're going to be dividing the 3,280 divided by 0.13. And why I do this method, guys, because at the point of making this video, my students would have had a limited, I think, knowledge on the principle of transposition. So I'm really teaching a concept that requires some deeper algebraic skills that at the point of making this video, or at the point of teaching these students, they are not well equipped at this technique. So we have to use this method that I call the golden rule, and using the opposite operation to isolate your variable. So you will find here that if I grab my calculator once again and I type in 3,280 divided by 0.13, we'll end up with 25,230. So that's going to be 25,230 .77 rounded off. All right, and that's going to be the amount of sales that is made for that month. All right, beautiful. 3 marks. So the math is not really difficult. As you can see, it's just a matter of applying the principle of mathematics in the question here. All right, beautiful. So that takes care of that worded problem. Then we're going to be moving on to, we're coming down to now, say here, question 5, I believe it is. We are at question 5A. And so I added this question just to cushion my students a little bit, you know, just going back to a little bit of the fundamentals, you know, the principles of Pemdas and the principles of operations with integers. Ladies and gentlemen, a link is pinned in the description and also in the comments of this video, where you can have a link that will take you directly to the live class on Pemdas teaching, and also I have some Pemdas practice papers on my other channel as well. Also, I have integer videos that I posted earlier last year. So if you guys are still a little bit weak on integers using the O&half technique, then you also can check that out as well here. All right. Also want to take the opportunity, I know that this is not related to mathematics, but I definitely would like for you guys to see how I use my mathematical skills in another department as well. I am a professional pool instructor. For those of you who guys don't know about pool, or you don't know about billiards, then you will learn that I'm also a professional player as well. You will see images floating on the screen here, guys, of videos that I've done. So if you guys would like to see me in my element outside of my classroom, you guys can check that out as well. A link will be pinned at the top of the comments that takes you directly to my channel. So go ahead and subscribe, leave a like, and let me know your thoughts when you watch those matches as well. I'm a competitive billiards player as well. All right, let's dive into this here. 34, let's go to our long screen here. There we have it on screen. 34 plus 14, open bracket, 4 take away 5 divided by 7 plus 12 multiplied by 5 multiplied by 0.5 here. All right, now what I tell my students to do is that when you get questions like these, just to the side, and it won't hurt you, it won't hurt your working out, just go ahead and jot down PEM DAS. Remember that Pemdas rule is a fundamental and permanent mathematical mnemonic that we use to discuss the order in which calculations are supposed to be done. There are numerous amount of mnemonics such as BIDMAS, BIMDAS, BODMAS, BOMDAS. They're all the same, but I feel like Pemdas mnemonic opens up the fact that all these type of questions will come with varying type of signs, square roots, raising numbers to a power, fractional powers, all these different things here. So let's check that out. First thing we want to do here is to try to check to see are there any P's, and we're going to work out any questions that are in the P section of the problem, and the P stands for parentheses, or more commonly referred to as brackets. So now we have a bracket here. We're going to have 34. I always encourage students to write down everything else that is not related to the current operation that you're doing. So 34 plus 14, and remember that bracket means multiply, and we're going to work out what is in the bracket here. So we have 4 take away 5, that's going to give us -1. All right, so pay close attention, guys. Make sure you're looking on your paper to see what you would have left out. Then we're going to write back the divide by 7, and we're going to plus the 12 and times it by the 0.5. One step at a time, guys. One step at a time. Remember that this is most likely something that you're not going to see on a CSEC paper, but it's a principle that is applied in almost every question that you will encounter in the near future. All right, so beautiful. We have gotten rid of the parentheses. Let's cross off P. Let's look to see if there's any E, any exponents in this question. There apparently aren't any exponents in the question here, so that is crossing out E. Moving on to M, there are 2 multiplication aspects in the question here. So we have this part here to multiply, and we also have this part here to multiply. So we're going to write back everything else that is not in green. So we're going to have 34, pardon me guys, we have 34 plus, well, let's not put plus because we're not sure. Let's multiply. We have 14 multiplied by -1. That's going to give you -14. Now, some of you guys may have plus -14. That is also correct as well. But it's really 34 minus 14, because when plus collides with minus, we end up with a minus. Then we're going to divide here, say here, by 7 plus 12 multiplied by 0.5. If you're not very good at decimals, utilize the calculator, ladies and gentlemen. That's going to be 6. 12 multiplied by 0.5, that's going to be 6. Now, since we are finished with M, we can move on to D next. We'll realize that 34, and then we know that plus with minus is minus. We're going to be dividing the 14 by the 7, or better yet, we're going to be dividing -14 by 7. -14 divided by 7 is -2 plus 6. And then from here, 34, we're going to cross out the D. We're going to be looking to add or subtract first. In this case, subtraction appears before addition. So 34 take away 2, that's going to be 32, and 32 plus 6, that's going to give us 38 for our answer. All right, so that is the approach that you want to take to this question, ladies and gentlemen. Remember that memorization of mathematical concepts, once you memorize it, it is only temporary, and under pressure or under exam conditions, you are going to forget. So you guys have to identify your areas of weakness, and you can also reach out to me, even in the comment section on my social media. If you are watching this clip, you can reach out to me. I will source you links or images of questions like these that you can practice to hone your mathematical skills here. All right, and just to cushion a few of my students as well, I had to leave, just a little bit of a leeway. You don't want to, I don't like to pressure my students a lot, so I want to give them a chance to get some marks as well. So here we have 3 plus -7 minus 6, take away -8 plus 11 minus 13. You could just type it onto the calculator and get an answer of -3, or I think it's -4. I don't remember what it was that I saw on my answer sheet. But I always encourage students to show your working out. It develops your mathematical prowess. So here we're looking at sign clashes. We're looking at plus clashing with negative. We're looking at negative clashing with negative here. So let's rewrite. We have 3. And when the plus collides with the negative, we end up with a negative 7 minus 6. When the negative clash with the negative, we end up with a positive 8 plus 11 minus 13. And so we're going to be grouping like terms here. So we're going to have 3 with the negative 7. And be careful as well, guys, because I saw and I know that a couple students might accidentally put the bracket in between the negative and the 6. If you do that, you're going to end up having 14 as opposed to having 2 as your answer. All right. When it comes to the negative sign, you have to be very, very mindful. For example, here, if I did say here group the 11 from the 13, I would not be affected because plus is one of those signs that is neutral. But when it comes to negative, if you associate the negative away from the actual number that it's attached to, you're going to get a different result. So you have to be mindful when it comes to dealing with negative signs. I'm going to stick to the norm though, guys. I'm going to group my positive sign inside the bracket as well. So bracket by bracket using the O and half technique. 3 take away 7. That's going to give us negative 4. And then we have negative 6 plus 8. If your guys are not very equipped with the O and half technique, or you still make those little errors, feel free to use your calculadora. So negative 6 plus 8, that's going to be equal to positive 2. And 11 take away 13, that's negative 2. So then we go again and put it into groups. Pardon me here. I like to do it in groups of 2. So negative 4 plus 2, that's negative 2. And negative 2 minus 2, that's negative 4. All right, that's your answer. So it's negative 4 is the final solution then. All right, beautiful, 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 beautiful. All right, if you guys are doing well so far, of course, thumbs up to you, you're doing good. And if you guys have not grasped the concept, feel free to make the corrections and just make note and just prepare for the next exam, right? It's all a part of the process. In order for you to be successful, you've got to take accountability of your errors and work on them during your free time. All right, let's dive on then into, say here, the next part of the paper. So we have this final question before we enter into section 2. We have David, John and Michael are best friends who made an investment and earned a profit of $17,400, to which they decide to split it in the ratio A to B to C. David receives 24% of the total earnings and John received $3,600 while Michael took the remaining amount. Your task is to determine the values of A, B, and C. Now, this particular question, I believe maybe 1 or 2 of 100 plus students in my cohort this year actually got close to the answer, because it goes against the natural ratio questions that they would have seen in class. It goes against the natural ratio questions that you would see working on YouTube videos. It's one of those questions that test your ability to interpret what is required. Now, usually when you get a ratio question, they often tell you what the ratios are. For example, they say $17,400 was split in the ratio 2 to 4 to 5. In this case, we are not told what the ratio is, so we have to determine what that ratio is. But they did tell us the amount of money that each received. So we're going to be sticking to the normal method that I showed you in my ratio video. A link is also pinned in the description and in the comments of this video. Check out my ratio video, guys. It gives you the step-by-step process of how to master any and every ratio question. So we are told here that the total amount of income that was dispensed here was in fact $17,500. Let me grab an empty sheet for you guys here. Hold on, give me a sec. Okay, let's do it right here. So we're told that the ratio is, so we know that the total earning, or the total, the total earning is $17,500. $17,400, pardon me. And what we are told is that, I believe it was David, was it? Let's see, David received 24% of the total earnings. So we need to find David's amount. So that we're going to say David is going to be equal to 24 over 100 multiplied by 17,400. That will tell us the exact amount that David received. So we have, let's go on our calculator here, 24 divided by 100 multiplied by 17,400. And so David would have received a total of $4,176. All right. And then we know that, what was the name? I believe it was John. John, we were told exactly how much he got. So John would have received a total of 3,600. No calculation required there. And then, of course, we would look at the fact that Michael got the remainder. So Michael then would have gotten the remainder. So to calculate Michael's amount, that would have been 17,400 minus the amount received by David, which is 4,176, plus the amount that was received by John, which is 3,600. So if we go on our calculator and do this calculation here, we're going to have 17,400, pardon me, 17,400 minus 4,176 minus 3,600. We will find out that Michael would have received a total of $9,624. Now, fun fact, guys, that when I was writing the paper, I had a different thought in my mind. I wanted the ratio to come down to something really simple. But I'm not sure where I went wrong during the construction of the paper. Once again, my initial plan was not conveyed on paper. But regardless of the numbers, I ensured that I was going to get numbers that were close where they can actually be divided. So now what we have, and let's put a couple of boxes here. What we have here is David's amount. We have John's amount. And we have Michael's amount. So we're going to write that in a ratio form. David was first, John was second, Michael was third. So David was 4,000, whoops. So David is 4,176. And we're going to put a colon, just like a regular ratio. 3,600. I'm going to put a regular colon. And then we're going to have 9,624. Now, for any of my students who may be saying at the moment, sir, you did not teach us this in class. There are just some things that we won't have time to teach, and there are just some things, guys, that you're going to have to use your comprehension and interpretive skills. Not everything will be taught by a teacher. The concept may be taught, but the application is going to be your responsibility. All right? And if I were to show you a question exactly like this, I think that even some person would have still forgotten how to compute the problem. So this is how you actually work it out, guys. Okay? So now, depending on your timetable and how effective you are with your timetable, then you might be able to think that maybe 24, you know, if you can look at these numbers and visualize the largest number to divide it, then you can. What I like to do is that I always tell my students, start with numbers that are small. So I like to say, let's divide through by 2. Let's divide through by 2 and see what we get after that. Okay, so we're going to divide through by 2. So if I cross this out, let me jump on my calculator here. I have 4. So we're going to divide through by different constants until we reach a point where we cannot divide any further. So 4,176 divided by 2, that's going to give us 2,088. Again, we put back our colon. We're going to divide 3,600 by 2, so that's 1,800. And we're going to divide this number over here also by 2, so that's 9,624. divided by 2, that's 4,812. All right. Next, we're going to divide through by 2 again, because it does look as if 2 can work. Yes, 2 can work. So we're going to go ahead. Let's cross this out here and here. Let's cross this out now. Boom. Divide this by 2. We're going to get 1,044. All right. And then we're going to divide this again by 2. We're going to get 900. So see, it's coming down almost to like a small ratio value. And we're going to divide this by 2 again. We're going to end up with 2,406. All right. Beautiful. So then we're going to go ahead and divide through by 2 again. So here we divide through by 2. So if we knew our timetable, we could have actually divided through by 4. If we knew our timetable. But we don't. So we're going to take it step at a time. Divide through by 2 again. We're going to get 522. And divide through by 2 again. We should end up with 450. We're going to divide through by 2 again. We're going to end up with 1,203. All right. Now it doesn't seem as if, let's see here, it doesn't seem as if 2 can work. 2 can go into 450 and into 522. But it cannot, I don't think it can go into 1,203 because that's an odd number. And let's try 3. Let's check to see. I know 3 can go into 450 and I know that 3 can go into 1,203. But let's check if 3 can go into 522. Yes, it works. If you check it, guys, on your calculator, just type 522 divided by 3 and you're going to get 174. So now I think this is our final reduction here. We're going to end up with this is going to go 174. And if we divide through by 3 here, we're going to get 150. And if we divide through by 3 here, just to double check, make sure that we're good, we're going to get 401. So divide through here, we're going to get 401. Now, if you see these numbers, guys, the final ratio here is 174 to 150 to 401. I'm actually getting those values because, as I told you, during the construction of the question, I wanted the numbers to be a lot smaller. I had a number in my mind, but I'm not sure during the typing process, I may have typed an incorrect value there. But regardless, the ratio is 174 to 150 to 401. It cannot go any further. 174 is an even number. 150 is 174 is an even number. 150 is an even number as well. And 401 is an odd number. There are no divisible factors. In fact, 401 is a prime number. So there's no divisible factor into 401 other than 401 and itself. So it ends there. Ratio is, let's put some boxes around it here, 174 to 150 to 401. All right. So just use this information, guys, going forward into your next exam should you see a question like this here. All right, so we are going to head into section 2, but we're going to be taking a break, right? We're going to be taking a break, and I'm going to be running a video for you here that's related to my next channel. All right, you guys would like to check out some skills that I have on the pool table here. You have it, see it running on screen, and we're going to take a break and we'll be right back with more. We're going to be finishing up section 2 of the exam paper. All right, so I'll see you in a few, guys. And I'm kicking from a diamond on the short rail. Now the diamond here that I'm kicking at is diamond 4, and I'm aiming through diamond 10. So 10 times 4, that gives us 40. About 2 diamond increments below the first diamond after the side pocket here. So just here in front of the diamond here, we should make contact. Woo! Math mentally, and I prepare students for exam as well here. So here I'm kicking at the 3 ball and I'm aiming through diamond 12 and I'm aiming at diamond 3 so I can find the point on the rail to aim. Now once you shorten your angle, it is tended to go, it has the propensity to go a hair short. 2 and I'm aiming through the middle diamond, which is diamond 12. Now 12 times 2 is 24. Towards 24, then you will find that you get accurate results like this here. Wow. Alright guys, so I do hope that you enjoyed that little demonstration of my mathematical skills on the pool table. Like I said, I am I do multiple things on the YouTube. I have a motivational platform. I have a couple of TikToks as well. I have multiple YouTube channels that I'm currently working on. So if you guys would like to see me in my element outside of teaching, then of course feel free to take a trot over to that side of the channel. But all right, we're gonna bring this particular paper here to the end. We're going to bring this paper to the end. We're at section 2, as you can see here on the screen. Section 2 is optional, and I made it say here, just a second. So section 2 is optional. So for question 6a, it says the diagram below, which I'm going to put up on the screen in a second, guys. The diagram below represents the floor plan of a building with an office section, a hallway, and a storeroom. The floor is labeled P, Q, R, S, T, U, V and has the following dimensions. In fact, let me pull it up on the screen for you while I'm reading, guys. Right? Let me read it for you here. Alright, so there it is, guys. So that's the diagram that we're looking at. Let me just read over the information here for you. I have a physical paper in my hand. The diagram below represents a floor plan of a building with an office section and hallway and storeroom. The floor is labeled P, Q, R, S, T, U, V. There should be more. Should be W, X, Y, W, X, and Y. I left that off, guys. All right, and has the following dimensions as shown below. The length of WX, PY, QR, and RS are equal. I think I need to put it up on the screen for you guys to see the actual writing, because there were some non-verbal communications as well. So there we have it. The length of WX, PY, QR, and RS are equal. That means they have the same length. Using the information to determine and you're to show that the length of VW is equal to XY, 2 marks, and then we are to determine the area and the perimeter of the entire floor. Alright, so let's go back onto the diagram. One of the things that I did recognize, and I did hear some feedback and review, and this is something that I know that many students are guilty of, is that when they see the diagram, they fail to read the information that is up here, guys. You guys can't fail to read the instruction. Let me just highlight this. This information here, ladies and gentlemen, is key. A lot of the times, Csec, when they structure the questions, they put the key information in the reading. And I asked a few of my students, did you read the information? And they disclosed to me that they did not. They were just looking at the diagram and trying to figure it out. So that is also a downfall in many of you students when you're approaching the exam. You need to read the information, because the information sometimes may be on the diagram, as well as sometimes you may have to insert the information on the diagram yourself. All right, so that's something that you guys are in fact very, very much guilty of. So let's pull up the screen for you here. So this is a diagram that we're looking at. All right, and you can see that it is in fact labeled P. Let me just pull this out here, give me a sec. It is in fact labeled P, Q, R, S, T, U, V, W, X, Y. Those are the vertices of the actual shape. Now, the next thing that we're looking at here is the fact that they said that it's a office, a hallway, and a storeroom. Now, I like to, when I get questions like these, the first thing that I like to do is, even before starting the question, I like to sectionalize my question, because this is not a standard shape. It's a composite shape made up of other shapes. In this case, it is 3 rectangles. So there's a couple of ways that you could sectionalize this. I could sectionalize it like this if I wanted to, right? And then I could sectionalize it like that as well. So I could end up with 1, 2, 3, 4 rectangles. I want to sectionalize the diagram in such a way that I have the least amount of diagrams. So what I want to do here is that I want to sectionalize the diagram like, say here, this. So I want to sectionalize it here. Let me just use a blue ink, right, or a purple. So I'm going to cut it here, and I'm going to call this section here my office. All right, and then I'm going to call this section here in the middle the hallway. So I'm going to cut it down here, and this is going to be my hallway. And then of course this last piece down here, I'm going to call it my storeroom. And when I do it this way is that I'm trying to visualize and interpret what the question is asking me. So I'm sectionalizing my diagrams. Now, first thing that they said is that we should show that, and let's go back to the question. I think the first question was show that the length of WV. Let's identify where WV is. WV or VW. That's the line down here. We are to show that this particular line, so let's use a red here to highlight it. So we need to show that this line down here is actually, it says show that, let's check it here, guys. Okay, so we should show that VW or WV, either one, is equal to XY. Let's look at XY. XY here. Okay, so we have to show that. So basically you're asking us to show them why it is that VW is 9.4. Now, let's write something down here. So we're to show that VW is equal to XY. Now, when you get questions like this, you have to interpret the questions according to the lines that you're looking at. If you're dealing with horizontal lines, then you have to look at measurements that is also parallel to the horizontal line that you're looking for. Now, let me just zoom up to a section here. If you look at WV or VW, whichever one, right? VW or WV is in fact made up of UT and this. So these two lines here. So it is in fact equal to this line. So VW is actually equal to this missing piece here and the rest of this out here. Now we have 5.1. So we have a part of VW. And that part of VW is UT. So we can say that VW is equal to UT plus, and then this side right here, this empty space right here, if we parallel up and bring it up all the way here, you'll realize that it's the same measurement as here, 4.3. If you carry it down, you know that it lands right into this space right here, 4.3 as well. So that's going to be that 4.3 then is going to be RS. So that's going to be plus RS. So another way to visualize the length of VW is to say that VW is equal to UT plus RS. Csec likes when you do this sort of comparative relationship. All right. Now UT you would see already is 5.1. And we know that RS, so UT or TU is 5.1 and RS is 4.3. So then we have 4.3 here. And if we check it out, you'll realize then that that is equal to 9.4, which is exactly the same measurement as XY. All right. So whenever you get questions like these where there are sides that are missing, you have to look for the sides that are parallel into another section of the diagram. So how I was able to find this to be 4.3, how did I know that that was 4.3? Was the mere fact that I parallel shift and I go all the way up to see that there's a measurement up here of 4.3 as well. So I brought it down and aligned it with the 5.1, and then it basically added up to 9.4, which is the same measurement as XY. So that's something that you guys have to learn how to master when it comes to these types of questions here. All right, so that is it for that question. Now it did went ahead then to say that we are to determine the area and perimeter of the floor. So we're going to focus on the area first, then we're going to be focusing on the perimeter of the floor. Now, considering that this is not a standard shape like a square or a rectangle or a circle or a triangle, it is really a composite shape, and just based on the fact that we divided up the diagram here into sections, office, hallway and storeroom, then it seems as if the office, or it appears that the office is a rectangle, the hallway is a vertical rectangle, and the storeroom is in fact a horizontal rectangle here. So we're just going to say, we're going to write a statement then. We're going to write a mathematical statement. Let's grab a new page here. So we're going to say here then that the area of the floor, let's write out some words, guys. So we're going to say area of floor, and you don't have to do this in the exam. This is just for the purpose of teaching. So area of floor is equal to the area of the office, which I can put in bracket here, is a rectangle, REC. Remember, you don't have to write all these out for Csec, you can just get to the working out. And then that's going to be, so area of floor is going to be equal to area of office plus area of hallway which is also a rectangle, which you're going to see in a second. And we're going to add that then to the area of the storeroom. So area of storeroom, SR, storeroom. And that also is a rectangle as well. So that's how you have to break up the question, ladies and gentlemen. So we're going to start with the area of the office. So since area of office is a rectangle, then it means that the area of the office, so area of office is equal to length multiplied by width. So then you'd go on your diagram, and just write that clearer for you guys so you don't get confused. That's length multiplied by width. So we're going to proceed back to going to our diagram and looking at the office here, and this is the office section. And we're looking at finding the length and the width of that section of the diagram. So the office, you can see, let me just grab some different color ink here to highlight the sections you need to be looking at. So the length of the office here is 9.4. That's the length. And so the width would obviously be here, but the width is missing. Now there are some non-verbal communications that were on the diagram. If you notice that we have in fact a dash here, a dash here, a dash here, and we also had another one down here. There's a dash here as well. Those dashes, those little strokes on the sides, the non-verbal communication is that all those sides have the same exact measurement. So any side that has a dash on it, if I know what that side is, then I know what all the other sides are, because they're all equal. Now we don't have a measurement down here for this dash, and we don't have one for this dash that we're looking for, and we don't have one to this side here. But if you scroll up here, you'll realize that there's a dash where this 4.3 is. So that 4.3 then means that all the sides, including here, so this is going to be 4.3 as well. Let's put those in from now. So that is 4.3. This side that we're looking for as well is also 4.3. Hope it's not too confusing for you guys. And this side down here also is 4.3. We're going to need those measurements later on, so that's why we're putting them in from now. So then let's go back to defining the area of the office. We now established that the length is 9.4 and the width is 4.3. So if you go back to our calculation sheet here, you will find here that it's 9.4 multiplied by 4.3. And so if we grab our calculator here, let's grab it here. All right, so we have 9.4 multiplied by 4.3. We're going to end up with 40.42 centimeters squared. That's for the office. All right, good job. Now we're going to move on then to looking at the area of the hallway. So area of hallway. The hallway is also a rectangle. So the area of the hallway also is length times width. So let's go back to our diagram then and observe to see if we can find the length and the width of the hallway. Now it's easy for us here to recognize that the width of the hallway, or the length, the width of the hallway is 4.3. But we want the length, and so the length can either be, you can either visualize the length to be on this side all the way down here, or you can visualize the length to be all the way down here. So I'm going to use that side here. I'm going to use that side for the length because I can visualize the values here. Now this length here, there's a part of it that's missing because I have the 4.3 here and I have the 4.3 down here. But what I don't have is this middle piece here. But if you take that middle piece, which is a vertical line, and parallel or project it to the left, you'll also see that it matches this 4.3 right here. So this also, that middle piece is also 4.3. So the full length of the hallway is 4.3 plus 4.3 right here, plus the 4.3 down here as well. So the length of the rectangle here is 4.3 plus 4.3 plus 4.3, or 4.3 times 3, whichever way you want to look at it. So we can just drop it in here, that 4.3. So we can just drop it in here just because I'm teaching, guys. So the length is equal to 4.3 times 3, which will work out to be 3 4s is 12 and 3 3s is 9, so that's 12.9 centimeter. Just put it to the side here. So we're going to go back here and say this is 12.9. That's the length. So 12.9 multiplied by 4.3. We established that the width was already 4.3. So grab our calculator here. That's 12.9 multiplied by 4.3. 12.9 multiplied by 4.3. 55.47. All right, and then we're going to go now next to the hall room, the storeroom. So we're going to say area. So area of storeroom. So area of storeroom. The storeroom we have already established is also a rectangle, so that also is going to be length times width. And then we got to go to our diagram and observe what the length is. So we can actually use the length to be this side here. We can actually use the length to be this side down here. That can be the length. And we already established from the get-go that VW was 9.4. So let's go here and drop that in. 9.4. That's the length. And now we need to calculate the width. So the length and the width is 2.2. There we have it to the side here, 2.2. So the width is 2.2. So 9.4 multiplied by 2.2, that's 20.68. So we have all that written down towards the side. And this is why you guys were having the problem. It's the interpretation. I'm sure you guys are watching me working this out and you'll be like, oh, I could have done this. But you guys were a little bit nervous. Some of you guys were not fully prepared. Some of you guys missed out on sessions, missed out on classes, forgot to watch some of the YouTube videos. And then, of course, you're going to find a challenge. All right, but the important thing is that you guys have the solutions right at your fingertip. All right, these are all centimeters squared. Please remember, ladies and gentlemen, forgive me if I leave out any of my unit of measurement. That is centimeters squared as well. So therefore then, the total area of the floor is going to be equal to 40.42 plus 55.47 plus 20.68. So 40.42 plus 20.68 plus 55.47. Let's double check that again, guys. 40.42 plus 55.47 plus 20.68, and we get 116. So that's going to give us an answer of 116.57 square centimeters. All right, that's going to be the total area of the floor. Okay, so the math is not very difficult. It's really the interpretation, because so far we have not done much more than just multiply and use a bit of interpretive skills to find a few of the missing sides. So the math is not tough, it's just interpretation. All right, so that is the full area. We need to move on to the perimeter. I need a different page here, an extra page, pardon me. So we need to look at the perimeter then. And we know that perimeter, regardless of the shape, means distance around the shape, around the edge of the shape. Perimeter is equal to distance around. Alright, so if the perimeter means distance around, let's go back to our diagram and identify some key measurements that we need to pay attention to. So on our diagram here, we have a bunch of markups, but let's stay focused, guys. All right. So help me. Let's identify here. Let's start off with this side here. All right. And then we're going to go in this direction. Okay. So starting off with PQ, we know that PQ is in fact 9.4 because it's opposite to XY, which is also 9.4. Now, this is kind of a uniform shape to an extent because we have opposite sides are equal. It's a rectangle. So let's count up the amount of 9.4s that we have. Let's use our red ink here and identify. So we have 9.4. That's here. So we have one 9.4. We have another 9.4. That's 2. Do we have any more 9.4s? I believe that's it. No more 9.4s. Oh yeah, we have another 9.4 all the way down here. This 9.4 down here as well, this bottom piece, VW from the start of the question, that's also 9.4. So we have, as opposed to saying 9.4 plus 9.4 plus 9.4, we can just simply go ahead then and just say 9.4 times 3. That's the first part of this. So that's 9.4 times 3. So that takes care of those 3 sides in one. Plus, let's go back to our diagram. So we have already calculated PQ. Let's look at how many 4.3s we have. We have this 4.3 right here. That's 4.3 for that side. Plus we have another one up top here. That's 4.3 again. So that's 2. We have another 4.3 to the side right here, so that's 3. We have another one down here, that's 4 as well. I know it's a bit marked up, guys, but focus with me, focus with me. Let's start again. RS at the top here, which is 4.3. RQ at the side, which is also 4.3 because of those little dashes on the edge. We also have 4.3, which is PY to the side here, that's 4.3, so that's 3 4.3s. We have another one down here, that's 4.3 as well. All right, so that's it. So that's 4 4.3s. So let's go to our page and we have 4.3 times 4. All right, it's a much more efficient way of working out the question. All right, so just bear in mind all the sides that we have counted off already. So we have actually done PQ, start here. We have done PQ, we have done RQ, we have done RS. We haven't done this side as yet though. So let's hold on to that side. We have this extra 5.1 and we have this 2.2 down here. So we have 5.1 and 2.2. Let's just add those because they are not repeated. So plus 5.1 plus 2.2. All right, plus, go back to the diagram once again. This is a part of the process, guys. We have the 5.1, the 2.2. We have already taken care of the 9.4 at the bottom. We have already taken care of the 4.3 at the side here. And we have already taken in account the 9.4 that is below the office here. So the only side that we don't have in this measurement here is the side ST. All right, we don't have the side ST. Now, I know that the diagram is a bit jumbled up, but if you were following step by step, it's not going to be as jumbled up as possible. Now, have a look here, guys. ST is a partial line, and it runs all the way down towards the line VW or WV. Now, to find this side, we've got to be a little bit, we've got to be focused here, guys. Focus on what we're doing here. So, ST, we can compare ST to, let me see if I can grab a different ink just to get you guys up to speed. Hold on, give me a second, guys. Let's do orange. So we can compare ST to being equal to RQ plus the missing piece here. So RQ plus the missing middle piece plus this portion right here. This portion right here is missing. And so we know that all of this side here is 4.3. And if you compare it to this left side here, which is 2.2, if we take away 2.2 from 4.3, you would have get this piece that's left right here. It's not half. A few students assume that it's half the distance, which they would have been off by 0.1, which would have made a big difference. But it's actually not half. It's almost half, but not half. It is actually 4.3 minus 2.2. But let's put some words together first. We know that ST is going to be equal to RQ plus QX plus a little portion there. So RQ plus QX. So ST, let's put it down here. ST is equal to RQ plus QX plus that little piece that we said is actually 4.3 minus 2.2. So this is information that you generally would keep in your mind, guys. So that little half a piece that we had discussed earlier, that's that point. Now, RQ, we know, is 4.3. And we know that QX also is 4.3 as well. That's the middle missing piece there. And now we are now learning that 4.3 minus 2.2 is actually equal to 2.3. Is it? Let me see, 2.3, 2.1 actually, 2.1. So now we have three measurements that makes up the whole length of ST. So 4.3 plus 4.3, that's 8.6. 8.6 plus 2.1 is 10.7. So that's the side that we need to add here, 10.7. All right. So with that said then, now that we've gone through all that rigmaroles about getting to the answer, we can know that we can take our time then and say on the calculator 9.4, clear this, 9.4 plus, sorry, pardon me, 9.4 times 3, that's going to give us 28.2 for that part, plus, getting rid of all the brackets now first, 4.3 multiplied by 4, that's going to give us 17.2 plus the 5.1 plus the 2.2 plus the 10.7. And if we add that all up nicely, then we have 28.2 plus 17.2 plus 5.1 plus 2.2 plus 10.7. We get an answer of 63.4. Now, if you guys had a much more simple approach to this, remember that I'm putting everything on the screen so that a lot of students will be able to visualize what is it that we are discussing. So the final answer there is 63.4 centimeter. All right, that is the perimeter of the shape. So some of you guys got it right. You guys took a different approach to it. I like to write down stuff. All right, and if you can do it to the side of your working out, that's also fine as well. All the calculations shown on screen here are not completely necessary, but it's necessary for the viewers to understand the thought process here. So when you look at this diagram, it looks a bit complicated, marked up, but this is what your diagram is supposed to look like when you're done, because you have to be, this is all your chain of thought. All of this is your chain of thought. So that's important as well. So that is the perimeter of that shape there. All right, beautiful. So that takes care of that entire question. I should have given you students a bit more marks. Maybe I think that this question is worth about 9 marks maybe. I think I only gave you 8, so maybe I should have given you 1 more, but that's fine. All right, that's the end of that question. Now we need to take on the final question that will bring us to the end of the paper. And if you notice that even though on this paper formulas that were provided, to this point we have not even looked at applying those formulas. All right, a lot of the time CXC will give you an exam paper, and this exam paper will have a bunch of formulas that you may not necessarily have to look at, but in this case we didn't. All right, next one says the diagram below, which you're going to see on the screen in a second, not drawn to scale, is a composite shape consisting of a trapezium and a triangle with the given dimensions as shown. You're going to see that diagram in a second. The length of AB, there is that non-verbal communication again. The length of AB is equal to EC. Length of AB is equal to EC. So those, once I know AB, I know EC. And if I know the length of EC, I automatically know the length of AB. That might be some handy information here. So let's put a question mark here. We need to apply that. The point E, see, I have highlighted, I put it in bold. The point E is the midpoint of the side AD. Now, I may or may not have explained this whole concept of midpoint, but what midpoint means, ladies and gentlemen, boys and girls who are watching this video, midpoint means that the whole distance is going to be divided into 2. That means whatever the distance from this point is to this point is, where the point E is, will chop this side into half the length. So let's say that the whole length is 10 centimeter, then it means that this side would be 5 and that side would be 5. So that is what is meant by midpoint. The area of the trapezium is also 125. So of course you're getting some valuable information here, 125. And we're to use all that is stated here in the information to calculate the following. So what you see here on screen is just my thought process, my initial thoughts based on what I've read and what I've comprehended from what instruction. For those of you guys who did not read this information, then you will find that one of the reasons why you would have gotten the question incorrect, and one of the reasons that you would have found a challenge in the question would have obviously been the reason why you found this question challenging. So let's transfer our thoughts onto the diagram here. Alright, so let's go back to this fresh diagram here. Alright, just a second. It should be here anytime now. Okay, there it is. Ah, there we have it. Alright, so that's what we have. So we have the trapezium, which, let me just shade it for you here. This is obviously the trapezium. And if you remember correctly, that it told us that the area is in fact 125. So let's put that here. Area is equal to 125 squared centimeters. So let's drop that in. It also said AB, which is this 7.8 here, is actually equal to EC. It did say that. And here's EC over here, and there again, you see that non-verbal communication, that double arrow, or the double stroke, it means that those two sides have the same measurement. So let's just drop that in right away. We don't want to have to think about that later on. So we want to drop that in. So that's 7.8. Let's drop that in right away, guys. And that, we know that it's meters. We know that. So we're going to need that information later on. Remember, we also said something about E, right? When I was discussing here, let's go back to the page where we said that if we have a midpoint, what it means when we see E, it then simply means that we have found half the length. Or if we have the full length, then we can chop the full length in a half to find either side. Or if we have half the length, we just put the other length on the other side as well. So I hope you guys remember that initial thought process that we had earlier. So we know that before we even look at finding anything, we need to fill out some missing measurements. So we know that the whole length is 26.6. That means this side is going to be 13.3. That is 26.6 divided by 2. So that's 13.3 and 13.3. Once you're able to do this information, ladies and gentlemen, then it's going to be very simple for you to move forward. And that's going to be meters as well. Whoops. It's a big meter. And that's meters as well. All right. And that's it pretty much. So we have everything. We split AD into a half. We know that AB and EC are equal. And we know that the area is 125. And we have measurements on the side, 7.8, 24.4, 10.7 to the right, and 26.6 later on. So the first question that they had asked us then, ladies and gentlemen, let's pull that up on screen, is that we should find the height of the shape. They didn't tell us what shape, so we have to figure that out. We have to find the height of the shape ABCE. ABCE. Let's find that shape, guys. ABCE. So let's see here. A, B, C, E. So they're asking us for the height of the trapezium. Now, usually you're going to find that the height of the trapezium is usually somewhere here. Usually when you see a trapezium drawn, they normally have the height drawn here. But once again, the height isn't there, but we use that parallel technique or that parallel projection where this height of the trapezium is in fact the same height of the triangle. So if I can find the height of the triangle, then I can find the height of the trapezium. Or if I can find the height of the trapezium, I can find the height of the triangle. Now, since as we're trying to find the height of A, B, C, E, and that's a trapezium, if we look back at our formula sheet, then we could use the golden rule to help us. Because see here, we have the formula provided here for you. A plus B times H divided by 2. So if we then go ahead then and use the golden rule by writing down the formula, again, it's that golden rule that takes the guesswork out of mathematics. We've been talking about that all video. We know that area of a trapezium. So area, we don't need to write area of trap or area of trapezium. Just write area is equal to A plus B times H divided by 2. So A plus B multiplied by H divided by 2. In our trapezium class, again, you will find links pinned to every video, every question that is on this paper. You'll find a link pinned in the description and in the comments that will bring you back to a lesson talking about trapezium. Now, we did discuss in that video that in order for you to find the length of A and B are located where the arrows are. So if we go ahead then and we take a look at the arrow, you see an arrow here. Beautiful. So that arrow is going to be your A, and then of course the other arrow up here is going to be your B. And that is how the 13.3 plays an important role. Because had you not divided the 26.6 by 2, you would have either been tempted to use 26.6 as B, or you would have perhaps recognized that you do not know the value of B. So you guys may have or is experiencing that current predicament or that current challenge right now. But now we know that B is 13.3 simply because E is in the middle of AD, so it divides the 26.6 into 2. So B is 13.3, A is 24.4. Obviously the height is missing because that's what we're looking for, but the key thing here is that we were told that the area is 125. So we can put 125 here because that is the area. A is 24.4. B is 13.3. We're going to times it by H and divide it by 2. All right, and this is something that we've been through in the class where we learn how to reverse the formula. So 125 is equal to 24.4 plus 13.3. Well, 24 plus 13, that's going to give us 34, 37. 37.4 and 0.3 is 0.7, so that's 37.7. And then we're going to multiply that by H and divide it by 2. Now there's a couple of approaches to this. You can actually multiply both sides of the equation by 2 and balance. Right? You can do it that way. Or as I told my students, just check the easier way out. There is a constant on the left that does not have anything to do. We can't add, subtract, multiply, or divide anything to the 125. So we can go ahead and divide the 37.7 by 2. So 37.7 divided by 2. And we're going to end up with 18.85. So that's 125 is equal to 18.85. After we divide by 2, 18.85 times H. So if we times it by H, then the opposite of multiply, because the 18.85 is multiplying the H, we divide both sides by 2, we end up with 125 divided by 18.8, and I believe we should get 6.6. Let's double check that. We have 125 divided by 18.85. We end up with 6.63. 6.63. So that's just 6.6. That's the height of the triangle, and that is also the height of the trapezium. Okay. Now, alternatively, like I said, we could have just multiplied both sides by 2. So we could have said, say here, multiply here by 2, multiply here by 2 as well. So we'd have ended up with 250 on the left is equal to this 2 cancels this 2. So we'd have ended up with 250 on the left. And that's going to be equal to 37.7 times H. And if you go ahead and split the difference between the 37.7 and the H, 250, opposite of multiply to divide by 37.7, you end up with the same answer, 6. So if we say 250 divided by 37.7 as equal to H, H would still work out to be equal to 6.63 or 6.6 centimeters. Alright, so it's just really personal preference, understanding of the mathematical principles and application, and that will oftentimes get you to your solution. Alright, So that takes care of how to find h, or how to find the height of the shape ABCE. Let's move right along then to the second question. We're approaching the end of the paper, guys. We're about 2.5 hours in, and I could have gone a little bit faster, but as you see, guys, I'm walking you through the entire thought process and alternative approaches to this question. So here we have the area of DCE, the area of DCE. Let's go to our shape and touch D, C, and E to see what kind of shape does it form. So DCE, let's see here. DCE, where is D, guys? Okay, here we have D here, D, C, E. Okay, so that forms a triangle. So we need to find the area of that triangle. Now, we could go ahead and use half base times height. We could, but then we know the height, which is 6.6, but we literally don't know the full base. Or yes, we could say, unless that's, well, that is not an isosceles triangle either. So we couldn't say the base is 13.3. It would have had to be an isosceles triangle for us to do that. And because one side is 10.7 and one side is 7.8, we can't use 13.3 as the base. And we can't assume that the base is divided into 2 either. So we're not sure. So an easier method here would have just simply been to use the Heron's formula, because we have 3 sides here. 13.3, 7.8, 10.7, and that is why the Heron's formula is actually on the exam paper. If you look at it carefully here, I have the Heron's formula right here. So let's reenact, let's jump back to what the Heron's formula is. Let's rewrite that formula on the screen. This paper was a challenging paper. It challenged your interpretation, ladies and gentlemen. It's not a difficult paper in my opinion. And if you don't think it's a difficult opinion, leave your thoughts in the comment section as well. It required some practice, guys. So the area of a triangle with all 3 sides given is the square root of S bracket S minus A, S minus B, S minus C. And we know that we need to find the value of S first, which is A plus B plus C divided by 2. Now if we go back to our shape, A, B, and C would obviously have been 13.3, 7.8, and 10.7. So 13.3, 10.7, 7.8. 13.3, 10.7, and 7.8. So S is equal to all of that number divided by 2. Let's grab our calculator here. Okay, almost to the end, guys. Now it's a long class. 13.3 plus 10.7 plus 7.5. That's 31.5 divided by 2. That's 15.75. 15.75, let's use 15.6. Round it off. Okay. Could use 15.75, or even if you had used 15.7, that's also fine as well. So let's use 15.8. 15.75 rounded off is 15.8. Alright, that's both acceptable. Alright, so then we're gonna have area is equal to the square root of all of that. So we're gonna have S here, which is 15.8. Let's zoom it up a little bit here. Hold on, guys. So 15.8, open bracket, 15.8 again, minus the first value is 13.3, close the bracket, 15.8 once again because S repeats itself, 3 times 15.8 minus 10.7. And then we're going to have 15.8 again, finally, minus 7.8. I think I may have made an error. Let's double check on that value. 13.3 plus 10.7 plus 7.8. 31.8 divided by 2, 15.9. Interesting. We're going to use the 15.8 since that's already started. I think I made an error. I think I accidentally typed 7.5 instead of 7.8, but I hope you guys get the principle. So it really should be 15.9, guys. Alright, but let's just work it as 15.8. We're so far in and we need to close this video. So 15.8. Might as well we just calculate it from now then. So 15.9 is the actual answer, guys. So 15.9 minus, so we're going to replace all those 15.8 with 15.9. I made an error with my S, a slight marginal error with my S value. Alright, so 15.9 minus 13.3, 2.6. 15.8 minus 10.7, 15.8. Sorry, 15.9. See, I'm confusing myself, guys. 15.9 minus 10.7. We're going to get 5.2. And then we're going to have 15.9. I got it right this time. Minus 7.8. That's 8.1. Alright, then we're going to proceed to multiply that by the remaining digits. So that's 15.9 multiplied by 2.6 multiplied by 5.2 multiplied by 8.1. We get 1,741, 1,741.24. And if you go ahead and find the square root of that number, so that's the square root, so that's 1,741.24, and we find the square root of that, we end up with 41.7 squared meters. Alright, that is the answer. That's the application of that question. Right? Alright, beautiful, beautiful. Alright, and then finally we got into the end of this video. I know it's been a long one, but I hope it has been an intuitive one as well, and it's really helping you to gain more understanding the perimeter of ADCB. So the perimeter of ADCB, let's touch ADCB. So where is A, where is D, where is C, where is B? So we have A, D, C, B. We want the area of the whole entire, we want the perimeter of the whole entire shape. So the perimeter of the whole entire shape would have been the initial red values that we had: 26.6, 10.7, 24.4, 7.8. So that's going to be 7.8, 26.6. So 7.8, 26.6. Give me a second, guys. 26.6. Let's just write it out first. Let's finish strong. Perimeter is equal to 26.6 plus 7.8 plus 10.7, that's to the right, plus 24.4. Most times when you get a question, ladies and gentlemen, with numbers, if there's a number that is on the diagram, that you have not used in your calculations up to a certain point, it means that you may have been overlooking something. They're not going to put a numerical value on the diagram that won't actually be used. Right, it's going to be used in some sense. So let's see here. Proceed, wrapping it up. We have 26.6 plus 7.8 plus 10.7 plus 24.4. And we end up with a final answer of 69.5 centimeters. All right, it was in fact an extremely long paper, very long paper, 2 hours and 45 minutes. This is indeed a healthy little practice session, healthy little review paper. It took a lot, you know, we made some errors here, we overthink a little bit here, and I feel like this was an interesting class. Let me know your thoughts in the comments, guys. If you have gotten to this aspect of the video, this end of the video here, let me know your thoughts. Your end of term exam is coming up. That paper is going to be released also in December as well, along with some other classes. Again, guys, if you'd like to be a part of my online platform, wherever you're watching this video from, wherever in the world, and you are doing CC, SLC, SEA, CSEC, and or City and Guilds, and you would like some tutoring, or you like some private tutoring, fundamental math concepts, you know, rebuilding you as a student, you can follow all my social media platforms, and it's pinned in the description of the video and also in the comments as well. I want to thank you guys for staying with me for the whole entire 2 hours and 45 minutes. And if you have benefited from what the explanation here, and you are now boosted, ready for another week and another month, and to finish the term strong, leave a like button, pardon me, hit the like button, guys, subscribe and share this to your math community, your social media platforms, and your status reports. All right, until next time, this is Apex Selenio, Mr. Peart, your math guru, CSEC guru. Until next time, take care. Bye bye.